Recessed lighting installations require careful consideration of clearance requirements, especially when distinguishing between insulation contact, or IC, and non-IC rated housings. The clearance distance specified for recessed lighting encompasses the space needed between the housing and both insulation and other building materials like floor joists. AC housings are specifically engineered for direct contact with insulation. This makes them ideal for ceilings where insulation will be placed directly over the fixture. Non-IC housings, conversely, are not designed for insulation contact and necessitate a minimum clearance, generally around 3 to 4 inches, from any insulation. When installing recessed lighting in a drop ceiling within a basement, several clearance factors come into play. Firstly, ceiling height is a crucial consideration. Ideally, the ceiling height should be at least 8 feet to comfortably accommodate both the drop ceiling and the recessed lighting fixtures. Secondly, clearance from insulation is paramount. If insulation exists above the drop ceiling, utilizing IC-rated housings that match the insulation thickness becomes essential. Thirdly, clearance from floor joists should be maintained. The recessed lighting should be positioned at a minimum of 3 to 4 inches away from any floor joists or structural components. Fourthly, clearance from ceiling tiles must be observed. The bottom of the recessed lighting fixture should sit at least 1 inch below the level of the drop ceiling tiles. For optimal safety and performance, opting for IC housings and adhering to specific clearances is advisable. A clearance of 3 to 4 inches should be maintained from insulation, similarly 3 to 4 inches from floor joists, and a 1-inch gap below the drop ceiling tiles should be provided. It is imperative to consult the manufacturer's guidelines for precise clearance specifications, as these can vary based on the product and its intended application. Understanding electrical components is essential for safe and effective installations. When discussing electrical current, amperage measured in amps is a critical factor. Voltage measured in volts is another key element. Resistance measured in ohms also plays a role in the circuit's behavior. Considering these electrical characteristics is vital for selecting the appropriate components and ensuring proper operation. To ensure a safe electrical installation, several key practices should be followed. Firstly, always disconnect power before working on any electrical circuits. Secondly, use the correct tools and equipment for the job. Thirdly, inspect wiring for damage before making connections. Fourthly, ensure all connections are secure and properly insulated. Fifthly, test the circuit after installation to verify proper operation. When working with electrical boxes, it's important to select the correct size and type for the application. Factors to consider include the number of conductors, device capacity, and box location. Metal boxes offer durability and grounding capabilities, while non-metallic boxes are corrosion resistant. Proper box fill calculations are essential to prevent overheating and ensure safe wiring practices. Consider the box fill capacity in accordance with the National Electrical Code (NEC). The NEC provides guidelines for the maximum number of conductors and devices allowed in a box based on its size and type. NEC Table 314.16 provides detailed information on box fill calculations. Overfilling electrical boxes can lead to overheating and potential fire hazards. Therefore, it's crucial to adhere to NEC guidelines for safe wiring practices. In residential wiring, understanding circuit breakers is essential for safety and protection. Circuit breakers are designed to trip and interrupt the flow of electricity when an overload or short circuit occurs. This prevents damage to wiring and reduces the risk of electrical fires. Different types of circuit breakers are available, including standard, ground fault circuit interrupter or GFCI, and arc fault circuit interrupter or FCI breakers. GFCI breakers are used in areas where moisture is present, such as bathrooms and kitchens, to protect against electrical shock. FCI breakers are designed to detect arc faults, which are a common cause of electrical fires. Regular testing of circuit breakers is recommended to ensure they are functioning properly. This can be done by pressing the test button on the breaker and verifying that it trips. If a circuit breaker repeatedly trips, it's important to investigate the cause and address any underlying issues. Using the correct size and type of wire is crucial for safe and efficient electrical installations. Wire size is determined by the amperage of the circuit and the length of the wire run. Using undersized wire can lead to overheating and voltage drop, while using oversized wire is unnecessary and costly. Wire types are designated by letters such as THHN, THWN, and OFF, which indicate their insulation properties and suitability for different environments. THHN wire is commonly used for general-purpose wiring in conduit, while THWN wire is moisture-resistant and suitable for wet locations. UF wire is designed for direct burial applications. When selecting wire, it's important to consider the ambient temperature and any directing factors that may apply. Directing factors are used to reduce the allowable ampacity of a wire when it is installed in certain conditions, such as in a bundle or in a hot environment. Consulting NEC Table 310.15 is essential for selecting the correct wire size and type for a given application. Grounding is a critical safety measure in electrical systems. Grounding provides a low resistance path for fault current to flow back to the source, causing the circuit breaker to trip and de-energize the circuit. This protects people from electric shock and prevents damage to equipment. Grounding systems typically consist of a grounding electrode, such as a ground rod or water pipe, connected to the electrical panel. Ground wires are then run from the panel to all outlets and fixtures. It's important to ensure that all grounding connections are secure and properly installed. Ground fault circuit interrupters, or GFCIs, are life-saving devices that protect against electrical shock. GFCIs monitor the current flowing in a circuit and trip when they detect an imbalance, indicating that current is leaking to ground. GFCIs are required in areas where moisture is present, such as bathrooms, kitchens, and outdoor outlets. GFCIs can be installed as receptacles or circuit breakers. Regular testing of GFCIs is recommended to ensure they are functioning properly. This can be done by pressing the test button on the device and verifying that it trips. Electrical panels are the central distribution point for electricity in a building. Electrical panels contain circuit breakers that protect individual circuits from overloads and short circuits. It's important to label each circuit breaker clearly to identify the circuits they control. Electrical panels should be installed in a dry, accessible location. The panel should have sufficient capacity to accommodate all of the circuits in the building. When adding new circuits, it's important to ensure that the panel has enough available space and capacity. Overloading an electrical panel can lead to overheating and potential fire hazards. Electrical permits are often required for electrical work, especially for new installations or modifications to existing systems. Electrical permits ensure that the work is performed safely and in accordance with local codes and regulations. It's important to obtain the necessary permits before starting any electrical work. Electrical inspections are conducted by qualified inspectors to verify that electrical work meets code requirements. Electrical inspections help to ensure the safety and quality of electrical installations. It's important to address any deficiencies identified during an inspection to ensure compliance with code requirements. Working with electricity can be dangerous, and it's important to take precautions to protect yourself from electric shock. Always disconnect power before working on any electrical circuits. Use insulated tools and equipment. Wear appropriate personal protective equipment, such as safety glasses and gloves. Avoid working in wet or damp conditions. If you are not comfortable working with electricity, it's best to hire a qualified electrician. Hiring a qualified electrician ensures that the work is performed safely and in accordance with code requirements. A qualified electrician has the training, experience, and tools necessary to perform electrical work properly. Hiring an electrician can save you time, money, and potential safety hazards. When working with electrical wiring, it's important to understand wire color codes. Wire color codes provide a standardized way to identify the purpose of each wire in a circuit. Black wires are typically used for hot conductors, which carry electricity from the source to the load. White wires are typically used for neutral conductors, which carry electricity back to the source. Green or bare copper wires are used for grounding conductors, which provide a path for fault current to flow back to the source. Understanding wire color codes helps to ensure that electrical connections are made correctly and safely. When making wire connections, it's important to use the correct type of connectors. Wire connectors are used to join two or more wires together. Different types of wire connectors are available, including wire nuts, crimp connectors, and push-in connectors. Wire nuts are commonly used for general-purpose wiring, while crimp connectors are used for more secure connections. Push-in connectors are quick and easy to use, but they may not be suitable for all applications. It's important to select the appropriate type of connector for the application and to ensure that the connections are made securely. Electrical codes and standards are developed to ensure the safety and quality of electrical installations. The National Electrical Code, or NEC, is the most widely adopted electrical code in the United States. The NEC is updated every 3 years to reflect changes in technology and best practices. State and local jurisdictions may also have their own electrical codes and standards. It's important to be familiar with the applicable electrical codes and standards before starting any electrical work. Understanding electrical theory is essential for troubleshooting electrical problems and designing electrical systems. Electrical theory provides the foundation for understanding how electricity works and how electrical circuits behave. Key concepts in electrical theory include voltage, current, resistance, and power. Voltage is the electrical potential difference between 2 points in a circuit. Current is the flow of electrical charge through a circuit. Resistance is the opposition to the flow of current. Power is the rate at which electrical energy is transferred. Understanding these concepts helps to analyze and solve electrical problems. When troubleshooting electrical problems, it's important to follow a systematic approach. Firstly, identify the symptoms of the problem. Secondly, gather information about the circuit and the equipment involved. Thirdly, use a multimeter to measure voltage, current, and resistance. Fourthly, analyze the data to identify the cause of the problem. Fifthly, implement a solution to fix the problem. Sixthly, test the circuit to verify that the problem has been resolved. Following this approach helps to diagnose and repair electrical problems efficiently and effectively. Electrical safety training is essential for anyone who works with electricity. Electrical safety training provides the knowledge and skills necessary to work safely around electricity. Electrical safety training covers topics such as electrical hazards, safety procedures, personal protective equipment, and first aid. Electrical safety training helps to prevent electrical accidents and injuries. Regular safety meetings and refresher training are important to reinforce safety practices and keep workers informed of the latest safety procedures. Emergency procedures should be in place to address electrical accidents and injuries. Emergency procedures should include steps for disconnecting power, providing first aid, and contacting emergency services. Workers should be trained on emergency procedures and should know how to respond in the event of an electrical accident. First aid for electrical shock includes steps for ensuring the safety of the rescuer and the victim, calling for medical assistance, and providing basic life support. Rescuers should avoid direct contact with the victim and should use a non-conductive object to separate the victim from the electrical source. Basic life support includes checking for breathing and pulse and administering cardiopulmonary resuscitation, or CPR, if necessary. It's important to seek medical attention for any victim of electrical shock, even if the injuries appear minor. Maintaining electrical equipment is essential for ensuring its safe and reliable operation. Regular maintenance includes inspecting equipment for damage, cleaning equipment to remove dirt and debris, lubricating moving parts, and testing equipment to verify proper operation. Maintenance should be performed by qualified personnel in accordance with manufacturers' recommendations. Records should be kept of all maintenance activities. Lockout-tagout procedures are used to prevent accidental energization of electrical equipment during maintenance or repair. Lockout-tagout procedures involve disconnecting power to the equipment and securing the disconnect switch with a lock and tag. The lock and tag prevent unauthorized personnel from energizing the equipment while work is being performed. Lockout-tagout procedures should be followed whenever working on electrical equipment. Arc flash is a dangerous electrical hazard that can cause severe burns, injuries, and even death. Arc flash is a sudden release of electrical energy that occurs when a short circuit or fault occurs in electrical equipment. Arc flash can generate extremely high temperatures, intense light, and a pressure wave. Arc flash can be prevented by following safe work practices, wearing appropriate personal protective equipment, and using arc-resistant equipment. Arc flash hazard analysis is used to determine the potential arc flash hazards in a workplace. Arc flash hazard analysis involves evaluating the electrical equipment, the work practices, and the potential for arc flash events. The results of the arc flash hazard analysis are used to develop arc flash safety procedures and to select appropriate personal protective equipment. Personal protective equipment, or PPE, for electrical work includes safety glasses, gloves, and arc-rated clothing. Safety glasses protect the eyes from flying debris and arc flash. Gloves protect the hands from electrical shock and burns. Arc-rated clothing protects the body from burns caused by arc flash. The type of PPE required depends on the potential arc flash hazard. The electrical safety audits are conducted to assess the effectiveness of electrical safety programs and procedures. Electrical safety audits involve reviewing electrical safety policies, procedures, and training records. Electrical safety audits also involve inspecting electrical equipment and work practices to identify potential hazards. The results of the electrical safety audit are used to develop recommendations for improving electrical safety.